So in this video, I'll be going over how to model scenarios, word problems with sine and cosine functions, all right? So let's go over some key concepts and some other tips first. Then we'll go into some problems, all right? Okay, so let's first review the important parameters for sine and cosine. Let's first recall the general formula. That's these two over there. A sine of b times t minus c plus d, or change the sign to a cosine, okay? We have to remember d is the midline, or the horizontal line that runs through the center of the wave, or d is the average value of the function. You can take the max plus the min, divide by 2, okay? The amplitude is absolute value of a, which is the distance from the midline to the max or the min. The period, which is 2 pi over b, should be absolute values there. Let me fix that later, okay? But period is how long it takes for the function to repeat itself. How long is the key. So the units are typically in seconds, okay? The reason I'm going over this and also frequency, sometimes it gives problems give one or the other. Frequency is how often the function repeats itself. Not how long, it's how often. How frequent. That's the term, okay? So instead of seconds, the units are 1 over seconds, or maybe cycles per second, so you can see how often. Or sometimes it's in hertz, especially in lots of physics applications, okay? And sometimes B is called the angular frequency. Its units are radians per second, okay? C is the phase shift. Sometimes we notate it as the Greek letter phi, however you want to pronounce it. And B, by the way, is sometimes omega, okay? I'm trying to connect if you're taking physics. Sometimes they use these variables instead, okay? So phase shift is just the horizontal shift, okay? So we have to remember those key ideas, key concepts. And now let me go over some other tips and reminders, all right? Okay. Sine and cosine, remember, are just shifted versions of each other. Cosine is earlier by a quarter period. I went over this in the graphing trig functions video, the parent function video, okay? Cosine is just earlier by 90 degrees. Okay. We can just, in these modeling problems, the key idea is make things simple. Don't make your life harder than it needs to be. Okay. Utilize phase shift to your advantage. Phase shift is just the delay of the starting point. Okay. If you utilize phase shift, you don't have to worry about any reflections at all. All right. So let's go over this simple example. So cosine x is the solid curve, okay? And we want to obtain the equation for the dashed curve, okay? So cosine, if we define the starting point as the point when x is equal to 0, it's at the max, or it's 0, comma 1, okay? This dashed one, it got delayed. This max got delayed by 0.25. Or you can really say that it got delayed by to over here, or maybe to it's earlier by back here, but let's keep things simple. Let's pick the closest one. It got delayed by 0.25, okay? So that's the phase shift. So our, let me get my pen. Our C would be 0.25. It got delayed by 0.25, or it got shifted to the right by 0.25, yeah? Now, how do we get the period? It's just period is how long it takes for it to repeat itself. So from like this point over here to this point over here, that's the start of the next cycle, right? That would be a value of 1. So period is 1, which is 2 pi over absolute value b. I'm just going to write b. So b is just 2 pi. Okay, so we got all our horizontal stuff now. Now for vertical, where's the midline? Midline is at y equals 0. So d is equal to 0. And what's the amplitude? Amplitude is how much it swings up or down from the midline. So the midline's here. How much does it go up to the max or down to the min? It is 1. So there's a model right there. Okay. So we can make things very simple by saying our model is cosine 2 pi times x minus 0.25 with our A, D, B, and C. You could make things very complicated by doing y equals negative cosine 2 pi times x minus 0.75. That is also the same curve, but you have a different phase shift. You have a different phase shift, and you have a vertical reflection as well. Why make things complicated, right? And actually, if you noticed, this dashed curve is even easier to model with a sine. Why? Well, sine, the starting point is at the mid and then goes up to the max. So it matches exactly that characteristic here. So we kind of just did y equals sine of 2 pi x. Okay? So that would have been even easier. But because if the problem required you to use cosine, you do all these things over here. But if you have a choice, just use sine. Okay, so now let's go through one example. These are just taken honestly from this AP pre-calculus packet by this teacher. Okay, periodic phenomena, unit 3. Okay. Actually, I need my highlighters still. I'm trying to change. Okay, so we have this weird figure over here, this clock. Okay, and it says the figure shows a large clock mounted to a vertical wall. The clock has an 8-inch long moving minute hand. The center of the clock is at 120 inches directly above the floor. Center of the clock, so maybe let's start marking as we read. This is 120 inches directly above the floor. At time t equals 0, the minute hand is pointed directly up at 12. T equals 0, 12. Okay? However, the clock is not working properly and the minute hand is moving twice as fast as it should. Thus, the next time the minute hand points directly up to the 12, next time that seems like period, yeah? Directly up to 12 is at time t equals 30. Let me just underline those, okay? As the minute hand moves, the distance between the endpoint of the minute hand and the floor periodically decreases and increases. The periodic function h models the height in inches of the endpoint of the minute hand from the floor and the floor as from the floor and the floor as a function of time t. That's, I don't know, let me fix that on the floor as a function. I think that should be fine. Okay, so we want to model this guy with a sine and a cosine. That's the direction. I didn't read the directions, by the way. Okay, so I have to read it out loud because I already know what's on this. All right, so, and this is 8 inches long. Okay, so it's helpful to actually draw out the points. Okay, for some people. So I just suggesting you do this if it helps you. Okay, so at t equals 0, let me erase all these again. At t equals 0, the hand is pointing directly up at 12. What's the height? Well, it's also an 8-inch hand, right? So this is the length of 8. So the total height when it's pointing at 12 for the tip of the minute hand is at 128. Okay, so that gives us this point over here. Okay, and then the next time the minute hand points directly up to 12 is at t equals 30. So that's our second point. Okay, actually, let me get the highlighter. I need to get used to switching back and forth a little bit more. Okay, so I got this point, and I got this point. Okay, now, by nature of how sine and cosine are, the mids and the mins and the maxes, how far are they apart in terms of time? They're a quarter period. Remember that? So we had the period of 30. Capital T is equal to 30. How long it takes. So when it gets to the 6 down here, and what's the height of that? That is 120 minus 8, so 112. It is half the period. So what is half of 30? 15, right there. So we got that point over there. And again, I'm going over this slowly because I'm showing you how to think through these, okay? And then these mids are when this one is when it's at 3. This one is when it's at 9, okay? So the height is at 120. It's equal to the center of the clock, the height at the center of the clock, right? And then, again, they're a quarter cycle away from the maxes or the mins, okay? Or we can just do what's halfway between 0 and 15, that is the 7.5 right there. And what's halfway between 15 and 30, that is 22.5 right there. We could have added the quarter cycle, which is 7.5, okay? All right, so we have our points. The reason why it's helpful to actually draw these 5 points is to see the phase shift and all that, okay? So the sinusoid will look something like this. And then we'll continue on, okay? So we drew these 5 points. Now let's start getting the parameters. Well, I already got that period is 30. Which variable in our general form for sine and cosine? Let me just write cosine first. A times cosine b x minus c plus d. Which term is related to the period? It's b. It's 2 pi over b. So then b is 2 pi over 30, which is pi over 15. What's the units of this guy? Radians per second. Don't know if you need that, but this is in seconds. So this is radians per second. B is radians per second. Okay. All right, we got that. We got B. Let's get A and D. D is the midline. What's the midline? Right here. D would be 120. Amplitude is how much it swings up or down from the midline. So how much does it go up or down? It's 8, the length of the hand, right? So A is equal to 8. All right. Now, C, the phase shift will be different if it's sine or cosine. All right. So, let me highlight what I have already. B is the sky, D, and A. So we're missing C. So for cosine, it starts at the max. Yeah? Does the sky start at the max? It does, because it's at the hour of 12, at the top of the clock. So do we need any phase shift for cosine? Do we need to shift the starting point? Do we need to delay the starting point? No. So C is equal to 0 for this case. What about the sine? The sine we do, because where's the starting point? It either is back here, because it starts from the mid and goes to the max, right? Or we can pick this point over here, because it starts from the mid, goes up to the max. So how much delay do we need to put? How much phase shift do we need to put? 22.5. So we have our two models. For cosine, so it'll be 8 cosine of pi over 15 x minus 0 plus 120. And for sine, it will be 8 sine pi over 15 x minus 22.5 plus 120. Those are our two models. Of course, you could simplify this top one, just be x, like that. You could distribute this pi over 15 to the bottom one if you want. I'm not going to do that, though. All right, those are two models. So let's go over what I wrote over there. So this was just through getting the 5 points. Once again, hands on the 12 at t equals 0. So the coordinates are 120, 8. Hand on 12 again at t equals 30. So 30, 128. And then it's going to reach the 6 at the bottom of the clock in half the time, half the period. So that's why it's 15, 112. And then for hand on the 3, it's going to be a quarter of the period, or halfway between 0 and, halfway between when it's on the 12 versus to the 6, right? So that's 7.5. And then similarly, the hand on the 9 is 22.5, okay? And then midline is where the center of the clock is, because the hands swing up or down from there. All right, amplitude is how much it swings up or down from the midline. That's 8. Period we calculate because it told us that it repeats every 30 minutes. So we calculate B as pi over 15. Phase shift, this is where I went over the two cases where cosine starts at the max. This case, it already started at the max at time equals 0, t equals 0. So no phase shift needed, but sine was where I marked this guy over here. We needed to delay it by 22.5. Okay, and these are two possible models. I used the wrong variables over here. So replace the y and the x with h and t. My bad. Okay, and for these, it's best to check your answer with the graphing calculator. You can even use Desmos. This is how I plot these actually. So matches. Okay, let's do another one with a template. Okay, you'll see me do it live. It's not all printed out. No cheating. Okay, so a toy car travels around a circular track as shown in the figure above. The center of the circular track is at 20 inches from the wall. 20, all right. At time t equals 0 seconds, the distance between the toy car and the wall is 0 inches. So that's where I marked the starting point looks like. All right. The car completes one full lap around the track every 8 seconds. Let's highlight that. As the toy car travels around the track at a constant speed, the distance between the car and the wall periodically increases and decreases. The periodic function d models the distance in inches between the toy car and the wall as a function of time in seconds. Okay, so let's sketch one period of the curve. Let's get those 5 points like in the other problem, okay? So at time t equals 0, it's at a distance of 0 inches away from the wall. Okay, right here at the starting point, all right? And we know that it takes 8 seconds to complete the full lap. So at 8 seconds, it would be a distance of 0 once again. All right? And now it's at the furthest point over here in half the time, half the period. So half of 8 is 4, yeah? And what's the distance? Well, the diameter of the circle is 40. There's that point there. And then let's get the two other points, okay? It will be a distance of 20 when it's over here, okay? Because if you think about it, this is a circle, right? So this radius is 20. This is also a radius of 20, okay? So it will reach this point over here in how long? It would be half the time between 0 and 4, or a quarter of the period. So 2, notice 2 is a quarter of 8, the period. And over here would be 6. Okay, so let's sketch it to help us see it more visually. 0, 0. 2, 4, 6, 8. 2, 4, 6, 8. And we need 20 and 40, okay? So at 2, it's 20, 40, duh, duh. Like this. It'll look like this, okay? That'll increase again, and then like that, okay? To make it more like one of the sines or cosines. All right? Very bad sketch, apologize, but that's approximately how it would look, okay? All right, let's get the parameters now. Let's get the midline first. Clearly, the midline is at 20. Hopefully you can see that, okay? So D would be 20. What about the amplitude? Amplitude is how much it swings up or down from the midline. That would be 20, yeah? As well. All right, what's the period? period is how long it takes, so 8 seconds to repeat. So that's 2 pi over b. So then b is 2 pi over 8, which is pi over 4. Okay, by the way, these units are in inches. This is in radians per second. I don't know how important this is. Amplitude should be in inches as well, technically. Okay. Now phase shift. Remember, these are different for sine and cosine. They're shifted versions of each other. So technically, we can maybe model this with a reflection, but remember that overcomplicates things. So let's just apply some shifting. Okay. So if you want to model it with sine, where is the starting point for sine? It would be right here, because it starts from the mid, goes up to the max, so on and so forth. So we need to delay it by 2 seconds. So c equals 2. What about cosine? Cosine starts at the max. So that would be this point over here. How much do we need to delay it by? By 4. Keep things simple. Don't bother with reflection. So sine would be d of t is equal to 20. That's a times sine of pi over 4 x minus, what is c for sine? 2 plus d, which is 20. And for cosine, everything pretty much stays the same except the phase shift, and we change sine to cosine, obviously. So x minus, what's the phase shift? It will be 4. Okay, here are 2 possible models. Again, you could probably just do like d of t is minus 20 cosine pi over 4x plus 20. I think that would work as well. If you like doing that, by all means, but people get confused. So if you don't want to bother with any reflection, go with just phase shifting. Okay. That was with a template. Now let's do no template. So this is mimicking a test. You gotta do everything on your own. But I gave a hint here. Okay. The figure shows the pencil sharpener on a surface on a level surface. Point B is located at the end of the handle that is 2 inches from the center of rotation. The handle rotates in the clockwise direction and completes 2 rotations every second. Highlights. At time t equals 0 seconds, point B is located directly below the center of rotation. The center of rotation is 3 inches above the level surface on which the pencil sharpener sits. The center of rotation. So here is the center of rotation. If this is the level surface, like imagine it's a table or something, then this is 3. Okay. As the handle rotates, the distance between point B and the level surface periodically increases and decreases. The sinusoidal function h models the distance in inches between point B and the level surface as a function of time t in seconds. Okay. All right, so we got to model it with a sine and a cosine. So let's sketch what's going on once again. At time t equals 0, it's going to be t, it's going to be h, okay? Time t equals 0, point B is located directly below the center of rotation. So what's the height of B with respect to the table, the level surface? It is 1, because 3 minus 2, right? So at t equals 0, it is at 0, comma 1. And the handle rotates in the clockwise direction and completes 2 rotations every second. So this is my hints. Pay careful attention if the problem provided the period or frequency. Is this period or frequency? This is frequency. 2 rotations every second. 2 rotations or 2 cycles per second. This is frequency. So this one's easy. How many cycles or how long does it take for 1 cycle? It would be 1 cycle in half a second. Okay, this is, by the way, frequency. So frequency is 1 over period. So period is 1 over frequency. So period is 1 over 2, which is 0.5 seconds, which I just said not long ago, right? 1 cycle in half a second, then if it's 2 cycles in 1 second. Okay, so this period is half. So this will be 0.5. It will be back at a height of 1. Okay, and therefore it would get to the max height right in the middle, which is 0.25. So what's the max height? It would be 3 plus 2, because it would swing up here, right? So then it would be another 2 inches. So because the middle is 3 inches high, plus another 2 inches for the arm to swing up to the top. So it will be 5. So it'll be 0.5 comma 5. All right. And now let's get 2 more points in between. So you can imagine it would be at the center of the rotation, the height of the center of the rotation. So 3 inches, which is right in between 5 and 1, right? 3. That's right in the middle. 5 plus 1, that's 6. Divide by 2, that's 3. Remember, I did max plus min divide by 2 for the midline in the beginning of the video. So this would be at 0.125, right in between. And this would be some other guy, which we actually don't need. I'm not going to bother with it, actually. So this would be at 0.125, comma 3. Okay. All right. So what's the amplitude? Or let's get the midline first, actually. What's the midline? By the way, this is how it's going to look again, something like that, right? The midline is 3. Amplitude is 2. How much it swings up or down from the midline? So to go from 3 to 5, that's 2. Or to go 3 down to 1, that's minus 2. But amplitude, we want to make things positive, no reflections, okay? For modeling with simplicity, okay? Period is half, as we said, which is 2 pi over b. So then that means b is equal to 2 pi times 2, which is 4 pi. Yeah? Now phase shift. So let me even just write the model first. H of t is 2 sine of 4 pi x minus something plus 3, and cosine, which would be h of t, which is 2 cosine of 4 pi x, not x, so it'll be t, minus something, the phase shift, plus 3. Okay, so how much phase shift do we need? For sine, it starts at the mid, goes up to the max, so that's over here. So we need to delay it by 0.125. I'm trying to squeeze it in. Sorry, it's kind of small. Okay, and for cosine, we need to shift it to the max, which is here. So 0.5. So need the pen. 0.5 goes here. And that's how we can quickly get our 2 models now, right there. All right. Okay. I think this is good enough for this video. Definitely, there's lots of problems on the internet if you need more practice. So go look for those. You can even ask AI at this point in time to generate similar problems to help you get some practice as well. But hopefully you saw my thought process and procedure. You can mimic it if that helps you.